first video, we are going to review how to simplify a square root and also how to do what's called rationalizing the denominator, meaning making sure there's no square root symbol in the denominator of your fraction. So when we are taking a square root, we assume its positive value unless we are solving for x. Nothing on this page has us solving for x, so we always assume the positive square root. So square root of 25 is just 5. Again, if I was asked to solve, I'd have to consider plus or minus. If I'm just straight up, what is the square root of 25? We just say 5. For numbers that are not perfect squares, we want to think about how the number could break down into primes. There's a couple of different ways to do that. Some of you may have learned the birthday cake method. Some of you may have learned factor trees. I will show a couple different methods, and you can pick whichever one makes sense to you. If you want to break it down by primes, so remember primes are 2, 3, 5, 7, 11, etc. If you're going to break down by primes, start with 2 and divide by 2 as much as you can. So 72 divided by 2 is 36. I can still divide by 2, I get 18. I can still divide by 2, I get 9. 9 cannot divide by 2, so now I'm going to go to the next prime, which is 3. 9 divided by 3 is 3. And 3 is only going to break down to 3 and 1. Okay, then you want to pair them off. And only one from each pair is going to come out front. So we're going to cross off one of the pairs. Whatever's in the circle, so 3 times 2 in this case is 6. And again, 2 times 3. Whatever did not have a pair goes inside. So the square root of 72 is the same thing as 6 square root of 2. Okay, so that's a prime factorization tree, if you like that approach. If you learned the birthday cake method in Algebra 1 at some point, it works similarly. We take 243. Okay, 243 does not divide by 2, so I'm not going to try that. I will try 3. 243 divided by 3 is 81. Divided by 3 is 27. Divided by 3 is 9. Divided by 3 is 3. Divided by 3 is 1. 1 is like the candle on the top of the cake. We're still going to pair things off with only 1 from each group coming out. So I have 3 times 3 coming out front. And then I have this 3 left inside. So square root of 243 is the same thing as 9 square root of 3. Okay, so exact same approach, you just build upwards instead of downwards. I'm going to go ahead and jump over here to the square root of 108. Okay, so I'm going to jump here just to show you one other method. The other method is to just look at a number and think what multiplies to 108. So maybe you look at that and you think, okay, does 4 go into 108? So maybe you say, okay, 108 is 4 times 27. Okay, 4 breaks down to 2 times 2. 27 breaks down to 3 times 9. 9 breaks down to 3 times 3. So now I have to look at the bottom of each part of the chart to see what pairs. So it's a little bit less organized, but it is an option, and I know some of you kind of learned breaking down by your perfect squares. So that those 2's made a pair, these 3's can make a pair. So I have 2 times 3 coming out. This guy here staying in. So square root of 108 is the same thing as 6 root. I do not care which method you use for simplifying, you just need to commit to one or the other. For the sake of being consistent in notes, I'm going to stick most likely with this method here, breaking down by prime scalars. For this other problem that I originally skipped, this root 2 over 5. I can't reduce 2 over 5, so the next thing I'm going to do is split it into a top and bottom. I can't take the square root of 2. Square root of 2 doesn't exist. I can't take the square root of 5. But I'm not allowed to have a square root in the denominator. So we're going to do what's called rationalizing. So the bottom is what the problem is, so that's what I'm going to multiply by. And I'm going to multiply by root 5 over root 5. That's the same thing as multiplying by 1 because it's a number over itself. By doing that, on the top I multiply things that are in the root together. So root 2 times root 5 is root 10. On the bottom, the square root of 5 times the square root of 5 is the square root of 25. Square root of 25 is just the number 5. The 10 has a root, the 5 does not, so I cannot compare them. So root 2/5 is the same thing as root 10 over 5. So continuing practicing some of these, I'm going to work through this page with you, and then you will have some opportunity to practice on your own on Delta Math. So let's look at 135. If I don't know right off the bat what goes into 135, it ends in a 5. So I know 5 will work. 135 divided by 5 is going to be 27. You should be doing all of this without a calculator. This is all math you need to be able to do. 27 is 3 times 9, which is 3 times 3. It doesn't matter which 3's you pair off, so make a pair of 3's. Whatever's in the circle comes out, so I had a pair of 3's that comes out. Whatever did not pair, so in this case this 5 and this 3, stay inside. 5 times 3 is 15. So the square root of 135 is the same thing as 3 square root of 15. Okay, let's look at this next fraction 1. I can't reduce 1 over 25, so I'll split it to root 1 over root 25. I notice those are both perfect squares. The square root of 1 is 1, and the square root of 25 is 5. So that is my answer for this problem. I don't need to rationalize because the root went away in the denominator. Square root of 27, 3 times 9, which is 3 times 3. Make my pair. I have 3 coming out, and then this guy left inside. Let's try the square root of 45. 45 is 3 times 15. 3 times 5, those don't break down. There's my pair. Here's my leftover. 3 outside, 5 inside. Again, if you looked at 45 and said, oh, it's 5 times 9 and broke it down that way, that is fine. Root 9 over root 16. Square root of 9 is 3. Square root of 16 is 4, so that is your answer. Okay, root 3 over root 2. Square root of 3 is not a perfect square. Square root of 2 is not a perfect square. I have to rationalize because of the 2 in the bottom. That becomes the square root of 6 over the square root of 4, but the square root of 4 is just 2. So anytime you rationalize, the roots in the denominator cancel out. Root 2 times root 2 is just normal 2. So the answer to this is the square root of 6 divided by 2. I cannot simplify because the 6 is in the root, the 2 is not. Okay, let's try 85. 85 is 5 times 17. 5 does not have a pair. I can't write 17 down. It does not have a pair. So I have no pairs. If I put these back together, the square root of 85 just stays the square root of 85. It cannot simplify. Do a couple more together. Square root of 125. 125 is 5 times 25, which is 5 times 5. Again, make your pair. That comes outside. Whoever didn't have a pair is left inside. Square root of 125 is the same thing as 5 root 5. For 80, I look at 80 and I automatically think 4 times 20. So I'm going to change my approach on this. Okay. So 80 is 4 times 20. 4 is the same thing as 2 times 2. There's a pair. 20 is 4 times 5. But again, 4 breaks down to 2 times 2. So I have a 2 and another 2 coming out. 2 times 2 is 4. I have this 5 staying in. 4 square root of 5. This next one's a little tiny bit different. So square root of 4 over square root of 3. I can do the square root of 4. Square root of 4 is 2. I cannot do the square root of 3. This is a problem because square roots cannot be in the denominator. So I'm going to rationalize by multiplying by root 3 over root 3. And that gives me 2 square root of 3 over a normal 3 because these pair up. I do want to do a quick check to make sure this outside 2 does not simplify with what the bottom became. 2 and 3 do not simplify. So root 4/3 is the same thing as, root 4/3 is the same thing as 2 root 3 over 3. Square root of 49 over square root of 10. Square root of 49 is 7. I can't simplify 10. I could try it. 2 and 5. There's no pairs. Multiply by root 10 over root 10. Final answer is 7 root 10 over 10. And 7/10 does not simplify. I would highly recommend you pause the video, try these 8 problems, and then when you're done, play the video back so you can check your 8 answers. So go ahead, hit pause now. When you're ready, hit play to see what the answers should be for these problems. I'm going to talk through this next one in case you got confused by it, but 63 is 7 times 9, which is 3 times 3. I already have this 10 out front, so it's going to stay out front. So out front, I need 10 times 3, which is 30. Inside, I have this 7. Okay, same thing here. 2 is already outside. 300 is 3 times 100. Maybe you say 100 is 10 times 10. If you already found a pair, you don't need to keep breaking it down. You can, but it's already a pair, so why break it down? 2 times 10 is 20. 3 is Remember, on this one, we can't produce the 30 and the 5 because 30 is in the root, 5's not, and 30 can't simplify. So it was simplified to 2, 3, and 5. And then on this last one, if you didn't notice it and you broke it down, you would have had no leftover numbers. The square root of 196 is just 14. If there's nothing left when you break it down, everything pairs off, then there is no root left. Now that you have watched this video, you should work on watching the next video, and then there will be a Delta Math practicing both of these.